Hello, everyone, and welcome to the webinar. This is Sydney speaking, as you can see. This week's webinar will be going and we'll be talking about advanced, what we call transform operations inside SolidCAM. And actually, I'll be also teaching some new options or certain ways to work with it. As far as combining different transform options that we have together, one over the other. That's basically what today's webinar is going to be about, including one of the new options that we have inside transform of transforming from one coordinate system to another coordinate system. Now, what exactly is transform? Well, transform, simply put, is taking an operation or a set of operations and copying them from one place to another, whether copying them or moving them from one place to another on your machine, whether it be by means of linear moving matrix or actually placing it from one area on the machine to a different area completely on the machine or rotating it around a certain point. These are different aspects of transform itself. So let's actually get started with the webinar itself. And what we'll start off actually is we'll start off by showing you one particular part, and then we'll move on from this part. And at this point right now, we're just showing one part. Okay? Now, I've created operations over here, but what I'm going to do is I'm going to actually take these operations that I've created over here, and I'm going to suppress them as if they don't exist. I'd like to do these operations again with you so you actually understand what I'll be doing when I'll actually be doing the transform on certain operations. Okay, the geometries, I will not create geometries because they already exist. I'll use already existing geometries. Okay, so let's first get started off by actually doing all the operations. And the first thing I'd like to do is create a face mill operation. Now note for the moment, okay? Note for the moment that the home position right now is set at the middle of the part. And we'll explain why later and what happens if I were to move it. Okay, but just remember that for now. Okay, so we'll start off with a face mill operation. So I'll go into my 2.5D operations and use face. And I'll choose my geometry. In this particular case, my geometry, if I were to show it to you, is around that area over there. Okay. Now, next, my tool. I'm going to be using my face mill, which I have over here, a 40mm face mill. And my levels, I'm just going to leave my levels at my 0 level. Okay, I'm just taking off on the top surface, clearing off the top surface. And in my technology, I'm going to change this actually to spiral. After speaking to, sorry, not hatch, but spiral. After speaking to many tool manufacturers, and under their advisement, they actually says this is the actual best way to work with these type of tools, the face mill tools where you have inserts. Okay, so I'm just going to leave it exactly the way it is, calculate it, and exit. Let me actually show the part together with the stock and vise, and you can see that there as well. Okay, let's just do a quick simulation of the solid verify. And you can see that my tool is actually going around the part, spiral, clearing it off. Okay. Next, what I'd like to do is do a profile operation around the part itself. So I'm just going to go ahead and grab a profile operation. I'll choose the geometry that I have. Let me see which geometries am I going to use. I think I'll use that one over there, as you can see. The tool that I will be using will be a 16mm end mill. Excuse me. And my levels, I'll set my levels from the top over here up until the profile depth at the bottom corner over there. Okay, so that's all set. My technology, I'll do a rough as well as a finish. I'll have my step down on my rough go every 12 millimeters. We have my links. That's all set. No problem. I have my profile operation done over here. As you see, it went around the part itself. Okay, next what I'd like to do is start working on these corners over here. Now, when I work on these corners, what I'm going to do is I'm going to only work on one corner. Okay, I'm not going to make any geometries for these corners over here. Just working on this one corner over here. So the first thing I like to do is I'm going to do actually a toolbox cycle using the option of simple corner. And if I look at my geometry list, I'm going to take this geometry over there. That's the geometry I'm going to be using for my simple corner. My tool, I'm going to be using the exact same end mill I had before, the 16 millimeter end mill. And my levels, my upper level will be over here, as my lower level will be up until that step over there. I'll just leave my technology the way it is, path, and I'll do zigzag and save and calculate. Quick run of the simulation, and you can see I basically machine that area up until that step. And I want to continue with that corner from this area here, so I'll create a new operation. Actually, just copy that operation, and I'll choose a different geometry. This time I'll choose this geometry that goes around the part over here. We can take a look at the top, and you can see it's basically going around over there. That's my geometry. Excuse me. Tool stays the same. The levels do change, however. I'm going from upper levels over here, and my lower level will be down up until that point over there. Okay, and we'll do save and calculate. Again, looking at the simulation, you see now it picked up that area, worked in that area over there. Okay, now what I'd like to do is work on some of the pockets. For example, we have a pocket in here. I'd like to first start working inside over there. So I'll do a pocket operation. And taking a look at my geometry list, let me see. I'm going to be taking this one over here. You can see from the top view. That's the one I want to take from working in there. And my tool, I'll be using my next tool, my 12 millimeter end mill for that, where my upper level will be set over here, and my pocket depth will be up until, let me just go up until that point down there. Let me just grab it. Come on, there we go. Got it? And well, we'll just leave the technology alone right now, leave everything the way it is, save and calculate. I'd like to do another pocket operation, this time on these steps over here. This one and this one over here. So I'll create, save and copy this operation, choose a different geometry. This time it's going to be not that one, but this one over there, as you can see. And note that these two edges, this one over here and this one over here, are marked as open edges. Okay. Same tool, levels. My upper level is still the top. My bottom level is up until that floor over there. In my technology, since I have an open pocket over here, I can use my open pocket strategy. You say use profile strategy, approach from the outside, save and calculate. And now, if I take a quick look at that simulation, you can see that it worked in those areas. Oops, what I did forget, I'm only human, my levels, okay? My levels in this particular case is going to be from the top up until that surface over there, up until there, Okay, save and calculate, simulate, which is why we have simulation, so we can see exactly what we're doing. Hold on a second. I think I turned over the part accidentally. No problem. Okay, again, my level up until there. That's better. Okay. Okay, much better. Next, I still want to work on these areas over here. So I'll do another save and copy. Choose a different geometry. This time I believe it's this one over here, as shown over here. Working in that area. My tool, same tool, levels, lower level up, my depth is up until that floor over there. I'll still leave the option of open pocket the way it was. Save and calculate. Quick simulation, you'll see it's working exactly in those areas. And I still also want to work in these areas over here. So I'll do another save and copy. This time I'll choose a different geometry. As you can see, this is now the geometry I picked, these two over here. Whereas, reminder, this side and this side is marked as open edges. My levels, upper level, pocket depth up until that floor over there. Save and calculate. That was done fine. And one more pocket over here is this pocket inside over here. So this time, again, save and copy. And this time I'll choose, not that one, but that one. Now this one, it's a closed pocket. Let me first change my levels. My upper level, since this is machined up until that point already, I can start from there. And my lower level will be up until that point over there. Okay, note my technology, there is no open pocket. Save and calculate. And now I want to do one more pocket operation. Now note we have 4 pockets here. I'm only going to do the pocket this time over here. Just this one chain this time. Okay, so I'll do one more time, save and copy. And my chain geometry this time will be this one over here. Note it's only taking one chain. That's all I wanted over here. I'll be using a smaller end mill, a 6 millimeter end mill. And my levels will be set, whereas my upper level is over here. My lower level is set from the bottom to the bottom over there. Okay? Again, this is not an open pocket, so there is nothing to do over there with the open pocket, and that's all fine. And that's all done, as you can see also in the simulation. Now, one more operation I'd like to do before I start work going into the transform issue. I'd still like to break the edges on these on the parts over here. So I'll quickly do a recognition operation of chamfer recognition. Okay, whereas I choose the geometry I already created beforehand. As you can see, all the edges were chosen over there. My tool will be a chamfer, and in my levels, I'm going to have a chamfer depth of 0.3 millimeters, whereas in my technology, I'm going to use 2 millimeter diameter of that particular tool, and my safety offset from the wall will keep it 1 millimeter away from those walls itself. Taking a quick look at the simulation, you can see basically it did that. We'll see the simulation a little later on in Solid Verify as well. Okay, now let's get into the issue of transform. You'll note that this operation, and this operations were all done over here. Now, all of them have to be done in these areas over here. Now, since this particular part is symmetric, I can actually rotate it around the center over there. Now, in this particular case, the center of the part happens to be my home position as well. So when I do the transform option, right click, we'll go into transform. We'll choose the option of rotate. Now, I'll choose the option of list. I'll include the original operation, which is this one over here, and I'll say I want at a angle value of 90 millimeters to rotate a total of 3 times. When I add that, you'll note I have 4 areas, 0, 90, 180, and 270. Okay? That's all set. If I show you the tool paths themselves now, you can see all of them were done. Okay? Quick simulation running Solid Verify. You can see it all being done, all of those operations, those particular operations. Okay. Now, that's all nice, but what happens if the home position is not in the middle? Okay? Let's go, for example, and make a little change. We'll go to my coordinate system manager, and we'll actually edit the position of my coordinate system. By clicking on Edit, I'm going to say, let's put it at the top corner of the model box. I'll just click on the part, and it's moved to over there. Okay? We'll just accept that. Now, obviously, the geometries, the operations have to be recalculated. So let's calculate all. And let's take a look now at the tool path that we have at this point of these 3 operations. If I were to show you the tool path, what we can see is it's being rotated around the 0 point. Starting off here, that's exactly what you got, but this is not what we need. We need it rotated around the center. So let's go back to these operations here. And we'll go back at the transform. By double-clicking on this, what we have over here, it brings me into the edit stage. Now, what I'm going to do is very simple. I'm going to add the option of rotate mirror point. In other words, I want to choose where, around what to rotate. Click on that. Now, if you'll note on the part, I'll zoom in a little bit on it. I have a point I actually created over there, which is exactly in the middle. So if I go pick that point, you can see it's moved to 125 by 125, and accept that. Let's take a look now at the toolpath I have. You can see now it was moved over to those points. In other words, I can rotate it now as well around a specific point. Okay, now what we've seen here is rotating around one part. Now let's take a look at what happens if I have the same part but in a different situation. And what I'm going to do is I'm going to open up this part over here. The exact same part, but this time my stock is this large plate. When I have this large plate in this particular case, I can actually do 4 parts as you see over here. So how am I going to work my rotate and do all the parts as well? Here's what I'm going to do, what we call a combination of rotate of certain operations as well as transform, what we call transform matrix. Again, we'll take these operations that we have over here. We'll do exactly what we did before. Rotate, list, include the original, rotated from there 90 degrees 3 times, add, and pick my rotating point, the center over there. Okay, that's done. Okay, now what I'm going to do for these parts, for these operations, is I'm going to add another, I'm going to take what I did over here, this transform over here, I'm going to add another transform to that. All I have to do now is click on Translate. If I click on Translate, let's use the option of matrix. This is a set linear translate option, where I tell it how many parts in the x direction, how many parts in the y direction, and the step over between one and the other parts. So let's go number of copies in x, 2. My x step, I check the x step beforehand, and it happens to be 275 millimeters. Now, number of copies in the y direction, also 2. Again, 275 millimeters. That's set. Okay? Let's take a quick look at the toolpath we have over here. And you can see now that the toolpath has been put on every single one of those corners. The transform, the rotate, as well as the transform. Now, I still have to, however, do transform to the rest of the operations. Well, before I do that, let me actually talk a little bit common sense. The first operation that I had before face mill, I'm not going to transform that. But what I've done here instead is I just used a different geometry. Because this time the geometry, I can use it on this whole stock over here. So I don't need transform with that. All I did was change the geometry. If I show you the geometry, you can see it's around my entire block over there. So when I simulate that, let's do that using Solid Verify. You can see now that it's going around that entire part. Okay, so transform in this particular operation is not needed in this case. Okay, but we do need it for the rest of the operation. So I'll take these operations over here, as well as the last one, transform, and we have translate. Exactly what I did before. 2 by 275, and in the y direction also 2 with a step of 275 as shown. Okay, accept that, and that's it. Now if I run my simulation on the entire part, you know what, let's do it actually using machine simulation. Excuse me. Okay, we'll zoom in a bit, and now we'll run the simulation. As you can see, the face mill working over there, working around the profile over there. You see now working on the corners. See, all of them are now being done. Every single one of them without missing one. Wherever where it needs to rotate, it rotates around the part, plus doing the transform in that particular case. Okay, let's stop the simulation now. Now what we've done here, we've seen the issue, we've added the issue of transform via matrix. Now, what happens if we have a different kind of a case? And this time I'm going to open up a different part, a different situation, same part with a different situation, where you have 2 parts in 2 separate vices, as shown over here. And if we take a look at the top view, you'll note that the vices are not even lined up. So using the option of matrix for the transform doesn't help us here. Okay? The rotate, fine, no problem. But as far as moving it over, we can't use matrix. So let's see what we can do instead. Okay, first let's do the transform, rotate around for these operations over here. In this particular case, I'm going to leave my home in the center position over there. We'll just do a quick transform, rotate, list, include original, and 90 degrees 3 times. Okay. Now what we're going to do is we're going to what we call translate list. Now when we go to translate list, let me just say okay for a moment. Let me take a look at the part from the top. Actually from over here is fine. I have to know the following. I have to know what's the distance in XY from this point to this point. And it's 350 by 50. Important information. So I go back into transform. And when I go into translate list, I'll say, okay, let's include the original. And over here, I'll write 350 by 50 by 0 for the Z. Click on enter, and it's over there. Okay? I need to do the same for the rest of the operations. So I'll take these operations over here, and do the exact same thing. Transform, translate list, include the original, plus 350, 50, and 0. Enter. Okay. Now if I were to run my simulation, and we'll use just a plain old solid verify simulation for this, you'll see that it'll do every single one of those operations exactly where it's supposed to do, according to the matrix, according to the transform list option. Okay. Now that it does this, there's one downfall with this particular way of working. First of all, I have to know what's the exact measurement between one part to the next point. That's the first thing. In other words, on the machine, I have to physically measure. Either I put it exactly the way it is over here, or on the machine, I first measure what it is over there and then put those values in. Now, what happens, let's say, in a month from now? You get a reorder for the job and you have to do the exact same setup. So what you have to do, one of two things. Either you go and put the setup exactly in the exact same place, measure everything out to make sure it's exactly the way it is in the program, or put it down on the table, remeasure, and then go back to the program and put those values in again. In other words, change the values that you have in the program. That's one way of doing it, but that's a lot of work. Let's make it a little easier. Let's see what we can do now to make it easier, in fact. Let's close this operation. What I'm going to do is in these operations where I have only the transform, I'm going to get rid of the transform itself. I'll do transform, clear all, so there's no transform on that at all. And on these two operations, plus this one, I'm just going to delete the second one with the translate list. Delete that one. So I still have the rotate. That I still want. Now let's see what I can do. First, let's go to my coordinate system manager. So I open it up, you'll note the following. I've created two coordinate systems, Mach 1 and Mach 2. One for this part and one for this part. So no matter where you put it on the machine, all you have to do is just create a Mach position for that. Okay. Now, what I'm going to do is as follows. Let's start off with these three operations over here. Transform. And what I'm going to do is simple. Use the option of coordinate system. Okay? And I'm going to say include the original coordinate system, Mach 1, and I want to use Mach 2 as well. And that's it. Once you have it set up this way, no matter how many times you come back and do the operation, you can put the fixtures wherever you want on the machine and just give it a home position, and that's it. You never have to come back and check the number to see if they're correct. We'll do the same for these operations over here as well. Transform, coordinate system, include the original and Mac 2. Accept that, and that's all done. Quick look at all of the toolpaths. You can see everything is being done exactly where it needs to do. Quick look at the Solid Verify simulation. Again, you can see everything is being done in its proper place, exactly where it needs to be done. Now, the issue of transforming from one coordinate system to another coordinate system is useful not only on these type of situations, but also in this particular situation. I'll load up the new part. It's where you have a series of parts on a tombstone, as shown over here. Okay, I have my first part as shown over here, and I'd like to move it to each one of these, what I've done on this part, to every single one of the other ones as well. And what I'd like to do is have a coordinate system on each one of those. Well, let me go into my coordinate system manager. Actually, let me erase what I have over here. And what I'd like to do is show you what we have. We have our first coordinate system. Okay? I'd like to create the other coordinate systems. Now, in this particular case, I can easily create other coordinate systems without having to go in each one and create one. What I can do is right-click on position 1, Mac 1 position 1, and we can actually transform coordinate systems. In other words, make new coordinate systems, create new coordinate systems via doing an option of translate and fourth axis. So actually, let's first do the translate, and I'll use the option of matrix. My X direction is only one part, so I'm going to leave it that way. My Y direction, I have 2 parts, where my step is 400 millimeters, and that's fine. Now I'm going to take that matrix that I did over here, and I want to rotate that around this axis as shown over here. You can see the axis over here, the point of that axis. I'd like to rotate it around that axis. So we'll go fourth axis, and I want you to create new coordinate systems at 90 degrees and do that 3 times. So I'm going to have these 2. You don't see the second one here yet because I haven't created it yet. But I'm taking these 2 that will be over here and rotating them 3 more times around that. We'll insert. Okay. I'm going to choose my vector. Vector consists of 2 points on the axis. So we'll choose my first point over here, and I'll accept that. And on the other end of that vector, I'm just going to click on that point over there and accept that. And we're all okay. Look what happens now when I create. When I click on create, I've created all of those coordinate systems without going to each one of them and creating them. Okay, now that I've created it that way, I could have, by the way, if I wanted, I could have gone ahead and created one in each individually. But in this particular case, since everything was so neatly, nicely lined up, I decided to do it this way. Okay, which I was allowed to do. Now, let's start my transform. First, again with these 3 over here, we'll do first the rotate option, transform, rotate, list, include the original, and add to the original 3 more at a 90-degree interval, plus rotate it around a specific point. I'll zoom in so you can see it a little better. This point over there. Okay. Now, in addition to that, I'd like to move it to different coordinate systems as well. So if I do click on coordinate system, you can see I have all of my coordinate systems over here. So I'll say include the original operation. Instead of clicking every single one of them, I can click on check all. As you can see, all of them have been checked. Now, not only that, if I want, I can also reorder them. Say, for example, I'm doing this one, then I'd like to go, instead of moving back down here, I just like to go straight over here and then back down. So what I can do is as follows. You have Mac 1, Mac 2. I'm going to take Mac 3 and move it down. So Mac 4 is before Mac 3. I'm going to take Mac 7 and move that down. I can reorder them any way I want. Let's just click on OK. And that was done. Need to do the same for these operations over here as well. So do that. Grab those. We'll do transform. Click on transform. And again, we'll use the option of coordinate system. Include original operation. Check all. Take number 3, move it down. Take number 7 and move that down as well. Okay? And we're all set. Now, in order for my machine simulation to be correct, I also have to make sure my setup, my machine setup is correct as well. So let me just go quickly in there. And you can see everything is set up. Everything is checked off over here. Moving exactly. In other words, everything is associated to the very first setup. No problem. Let's actually run my simulation. Run it first quickly. This way you can see all the tool paths. Go ahead. Just a moment. Operation, there we go. You can see all the tool paths on the part itself, all around. Okay? Let's do this actually using machine simulation, and you'll see it much better. Okay. Let's start the machine simulation and note the order that it works in. I'll slow down just a bit. You'll note it starts from here, goes up to here, then it starts, goes up, and then up, down. Down, up, down. Starts on this one, goes over to this one over here. That's because I was able to reorder it to make it a little more efficient. Okay? As it works down the part. You can see it works on all the parts exactly that particular way. Finishing off everything that needs to be done over there. Okay. So let's just do a quick review of what we've seen over here today. We've seen first the issue of rotating operations on a single part, whether it be around the coordinate system or being around a specific point, which is what we did in this part over here. We've also seen the option of what happens if you have a plate, a large plate as stock, we can do several parts. So you've seen the option of combining coordinate systems, in this particular case, using rotate together with matrix. We've also seen the option of what happens if I'm using the same part, but on 2 different fixtures, where we showed 2 options. One was combining the rotate together with transform list, and the other one, which is more advanced, using the option of rotate together with transform via coordinate system, which is extremely helpful in many cases, making it a lot easier actually to work, especially when operations come back at a later date. And this was also shown as well, not only on a vise as shown over here, but on a tombstone as shown over here, where not only did we transform the operations to different coordinate systems, we also actually transformed the coordinate system itself to create more coordinate systems as well. Okay. I would like to thank everyone for joining the webinar. And of course, the webinar was recorded and will be available on our site together with the parts. So everyone take care and have a fantastic weekend.